All right, our lesson today is going to be on graphing quadratic functions. So taking a look at a quadratic equation and being able to plot those points and draw your parabola. So it actually looks exactly like what we studied in the last topic. So this is just an example of kind of how everything's connected. We have our equation on the upper left there, y equals x squared minus 4x plus 5. We have our table of values. So we'll talk today about how to create this table of values. And then our ordered pairs, our plots. Notice this point, -1, 10, is right here in our table. -2, 17 would be up here. I just didn't have enough space to take a picture of that whole thing. But it would be up further on this parabola, keeping in mind that these arms of the parabola keep going, they extend, they don't actually ever stop there. I probably should have actually drawn in arrows to indicate that those keep going. They keep going up and outward the further they go. Now there is the vertex, so we can see here the vertex is at 2, 1. It's the bottom of the parabola, and I want to really focus on our table. So take a look at where that is in our table. It's in the middle, but when you look at the y values, notice that all of our y values will continue to increase the further away you get from that vertex. Okay, for example, 1 to 2 to 5 to 10 to 17. We're in the other direction, kind of the same thing happening. 2, 5, 10, and 17. And that's going to happen all the time. It's going to be like that anytime you're looking at the y values in relation to that vertex, that minimum value of 1 on the y-axis. So let's take a look at how we actually do this by hand. How do we graph this? So first thing we do is we need to make a table of values. And to do that, you can draw your table of values, but you choose your x values. And for today, at least, your x values will be chosen for you. I'll give you those. You don't have to try to figure out what they are on your own. But eventually, in a future topic, you will learn how to decide what x values to use. So once you have your x values, just substitute each x value into the equation and then solve for each y value. Pretty straightforward, just like you did with graphing linear equations back in Algebra 1. Then the other piece is just how to graph. And just like we did with linear equations, you just take the data from a table, you plot each point, you make sure that you've identified what the vertex is and some of the points on either side of the vertex, and then you just draw a smooth curve through those points so that it looks like a parabola. So let's see what this looks like. So here we have y equals x squared plus 2x minus 7. I can see in my table of values I have x values of -3, -2, -1, 0, and even 1. You can really start anywhere, but I'm just going to start with when x is -3. And I'm going to try to figure out what this y value is. So I take my equation, and I'm going to substitute in the value of -3 anywhere we had x in that equation. Okay, so I literally am just copying everything straight down here, but I'm making sure to put -3 in the place of x. All right, so now it's time to evaluate, and you could do this on a calculator, but I don't want to pull that up on the screen, so I'm going to do it the old-fashioned way and just kind of go one step at a time. -3 squared is -3 times -3, so that's 9. 2 times -3 is -6. So I get 9 plus -6 minus 7, which is the same as, let's see, 9 plus -6, that's 3, and 3 minus 7 is -4. And I repeat, I do the same thing when the y value, or excuse me, the x value is -2. I'll do that down below here. So y equals x squared plus 2 times x minus 7, and the x value is -2 this time. All right, so -2 squared is 4. 2 times -2 is -4. And 4 plus -4 minus 7 is -7. So I get a y value of -7 in that case. And I just keep doing that. I'm going to go ahead and erase my old work here. And my next one. So y equals x squared plus 2x minus 7. And my next x value is negative 1. Well, negative 1 times negative 1 is just 1. 2 times negative 1 is negative 2. So 1 plus negative 2 plus negative 7 would give me negative 8. Next, my x value is 0. So 0 squared plus 2 times 0 minus 7. Well, I know that 0 times 0 is just 0. 2 times 0 is just 0. And 0 plus 0 minus 7 is negative 7. And last one we have is when we have an x value of 1. So we have 1 squared plus 2 times 1 minus 7. Just a reminder, I'm using this equation and I'm just putting the x value in the place of x. All right, so 1 squared is 1, 2 times 1 is 2, 1 plus 2 minus 7 is negative 4. All right, so we have our ordered pairs. Now it's time to plot them, to graph them. So let me go to the next page, and there we go. That's a much better picture for us. So plotting our points, we have negative 3, negative 4. Okay, so remember the x value comes first, and my x-axis is the one that goes across. So I'm going to go to the left 3, and then for negative 4 as a y-coordinate, I go down 4, and I try that again. Negative 3, negative 4. There we go, worked that time. Next, I have negative 2, negative 7. So my x value is negative 2. I go to the left 2 spots. My y value is negative 7. I go down to negative 7, place a dot. And I have negative 1, negative 8. So I go to negative 1 on the x-axis. I go all the way down to negative 8 on the y-axis, place a dot. Now notice my numbers changed at this point. I was going down, negative 4, negative 7, negative 8, and now my numbers start getting bigger. I increase those values, and there's kind of that symmetry happening. So the next point is 0, negative 7. Since my x value is 0, I don't go left, I don't go right. I'm just going to go down the y-coordinate to negative 7. And then 1 comma negative 4, I go 1 in the x direction, negative 4 in the y direction, and plot my point. And here you can start to see what that parabola looks like. If I wanted to know exactly, where else I should try to aim when I draw my parabola, I know it's going to go kind of up this way. And my next x value is 2. I could certainly use the x value of 2 and plug that into our equation. So 2 squared plus 2 times 2 minus 7. And that's going to give me 4 plus 4 minus 7. Well, 4 plus 4 is 8. 8 minus 7 is 1. So that actually gives me another point. And I think, if we remember from a previous lesson, we have symmetry. If our vertex is down there at the lowest point, negative 8, I know that this is, so I went to the right of this red dot and up to that level. I can go to the left of this last red dot and up to that same level. I'm going to have that symmetry. So I can actually use symmetry to plot additional points too. So I have my vertex. I'm going to go ahead and just draw in my symmetry line or axis of symmetry. And then I'm going to draw my curve, making sure that I try to make a nice, smooth, rounded curve at the bottom. Going through my points as best I can and making sure that you put arrows at the top, okay, or at the ends, I should say, at the ends of each arm to indicate those keep going. They don't stop there. All right, so there's a nice picture of my parabola. I have my vertex down here at the bottom. I even see I have a y-intercept at negative 7. I see that I have a couple of x-intercepts. I can't quite tell exactly what those are. It looks like 1 point something and negative 3 point something. But definitely some of our key features. Parabola opens up, and there's a minimum value at the bottom. Let's look at one more. I'd encourage you to pause the video and try this one on your own, see if you can get the values the y values when x is 0, 1, 2, 3, and 4. So on this first one, when x is 0, just something to watch out for because of that negative sign. Make sure that you use parentheses around your x value anytime you're substituting. Sorry, I don't know why that switched colors. Not that this is going to make a difference when it's 0, because there is no such thing as negative 0. So 0 plus 0 plus 2 is just 2. But on the next one, it will make a difference. Okay, so I'm going to get rid of some of this. So on the next one, my x value is 1. So I'm going to treat it as 1 squared plus 4 times 1 plus 2. So the negative is going to stay there. I do 1 times 1, not negative 1 times negative 1. So negative 1 plus 4 plus 2 ends up being 5. Then when x is 2, just have to change a couple numbers. Again, that negative sign stays out front. It's not negative 2 times negative 2. I do the 2 times 2 first and keep the negative with it. 4 times 2. So this one ends up being, let's see, 4 plus 2 is 6. All right, next one, when x is 3. Again, it's not negative 3 times negative 3. It's just 3 times 3 with a negative in front. 4 times 3 is 12. All right, so negative 9 plus 12. Let's see, that's 3. 3 plus 2 is 5. And here I notice I get the same y value. So I've reached that vertex, that high point of 6, and now it's starting to step back down the exact same way that it was stepping up. Okay, so it was going in one direction, getting smaller. In the other direction, we're going to also get smaller. So we are going to know that that's just going to be a 2. You can always test it and check it. In fact, let's do that so I can prove that that works. For an x value of 4, 4 times 4 is 16. And here, 4 times 4 is 16. And I think you can see right away that that's going to be 0 plus 2, which is 2. So it does work out that way. So we're going to take those values, we're going to plot them on a graph, we're going to draw a smooth curve and call it a parabola. So plotting your points, okay, you're just doing x comma y, so go in the x direction first, y direction second. So for 0, 2, I'm just going to go up. For 1 comma 5, 2 comma 6, 3 comma 5, and 4 comma 2. And this is a time where, again, you could try to figure out what happens when x equals 5. It's just going to be down a little bit lower. It gives you another place to aim for when you're drawing your parabola. Make sure it's rounded at the top and not pointed. And there you go. We have our vertex at the top, which makes it a maximum value of 6. We have a y-intercept at 2. We have a couple of x-intercepts here that appear to be decimal values, like a negative 0 point something on the left side and 4 point something on the right-hand side. We got all those different features of a parabola that opens down this time.